Hello guys, hello everyone. My name is Karan Virmani. I'm a DevOps expert. Uh, I am passionate about teaching. So this video I am recording on Prometheus. Prometheus is a monitoring solution, and this is the agenda for today. So we're gonna discuss about like why Prometheus. Then we're gonna deep dive on the architecture of Prometheus and a lot of things. So this video is a theoretical video. If you're looking to set up Prometheus, then I think you should check my other video where I'll be setting up Prometheus using Helm charts as well as Grafana. And there is one more type of setup which I'm going to do it with the binaries, you can say. And there's an integration with the Grafana. So that will be the practical video. The second one, this is the theoretical one. Okay, let me just quickly start. I have prepared a small presentation for that. Just let's get this started. Okay, so now uh, Prometheus is nothing, just another monitoring tool. Uh, there are a lot of other monitoring tools are available in the market as well. Netcool, Datadog, and SolarWinds, and a lot of monitoring tools. So now, why Prometheus is there? So let's first discuss what all things we can monitor with Prometheus and why it is like really promising. So the first thing would be, so Prometheus is there to monitor the highly dynamic container environments. Okay, as we know, these days DevOps is getting complex day by day, and there are like a lot of interdependencies between pods, between containers, you can say, and so it's getting complex. So Prometheus is one of the promising tool whom we can utilize to to get those complex solution in an easier way, because it's going to give us the actual errors, actual you know the things which we need to resolve any problem. So we can monitor containers. We can, it's not only focused on containers, we can also monitor like virtualization, like the Linux server or Windows server. We can also monitor the bare metal. It's a bit difficult to set up on the bare metal, but I think it is useful. It supports the Docker Swarm. It also, we can also monitor the whole Kubernetes architecture by this tool. Okay, so now let's see why Prometheus. Why Prometheus is required. Mm, yeah, this is just a picture. Hey, why? But I can't hear you. So now just ignore the Kubernetes. So now let's understand why we need Prometheus and why it's important. Okay, so now let's consider these three pods: 1, 2, and 3. The first pod, let's consider. I'm just going to give you an example why we need the Prometheus. Okay, so first pod, let's consider this. This is a database pod, and the second pod, let's consider this is an pod required for authentication, and the third pod, this pod is there for the users. Let's say a UI pod. Okay, so now this database, this backend pod, let's suppose there is a problem with this pod. Let's say there is a memory crunch, or we can say a high CPU or a high network utilization, okay, on this pod. Now what happens is, because of, let's say, because of memory, we got an error that OM out of memory and this pod got killed. Okay, now what happened is, this authentication pod, it basically takes the request from the UI pod and get the credentials from the database, and that process is not working now because this pod got killed. Now what happens is, whenever an user trying to log in, the users are getting can't log in error. So let's say, being a DevOps engineer, if I start troubleshooting, first I will check on the UI pod, on the front end pod, that what is the problem, and from there I will got to know that I'm not getting the appropriate response from the authentication pod. I'm going to go to the next pod, which is the authentication pod. From that pod, the logs of that pod, I will got to know that why, what is the problem. I got to know that my TB pod is out of memory. There is no memory left. So either I had to create a new pod, I had to restart, or maybe we have some replication systems available. We can, but the point is, for that particular amount of time, if any request coming from the users, that will not was not that will not be successful. So in this scenario, we are looking for a promising solution who can provide us the exact source, exact target error. So Prometheus is one of the solution who is really accurate in the market right now. That's why there is like a lot of opportunity and the requirement on this tool. Uh, so uh, so that's why we need Prometheus. Now I'm just gonna talk about the architecture. So this is something where we're gonna deep dive today. Okay. So this is I'm gonna discuss like all the components which you can see on the screen. Okay. So one by one, first I'm gonna talk about, let's say, the Prometheus server. So first I'm gonna talk like theory about all these, and then I'm gonna show some websites like let's move on to that. Okay. So let's talk about this Prometheus server. What is the role of the server? This is the server where our Prometheus utility is installed. Okay. Now this is the main component in this whole architecture. So there are three things here. First is the retrieval. This is basically just a retrieval worker. It's a kind of a data. The job of this retrieval worker is to get the data from the targets. But what kind of data? What kind of data? Let's say the CPU alerts or matrices, to get the data from the targets and provide that data to this storage server. So this is a database basically. This storage is a database. It's a time series database basically. It stores all the data which was retrieved by this data retrieval worker. Okay, now there is a third thing available here. This is PromQL. This is nothing, just it's an HTTP server. For now, just understand this, like this is just an HTTP server. The role of the server is to accept the queries coming from, you say, the external sources for now. Okay, so there are some certain queries which is coming to this PromQL. It's an HTTP server, and the responsibility of this is just to accept that queries. That's it. Okay. Now the thing is, let's move to the other component. So what are the targets? As I mentioned, like data is retrieved from the targets. Okay, so targets could be your Linux server, your containers, your pods, your services, any component of the Kubernetes, or any could be like bare metal. So all those are targets. And what are matrices? So matrices are nothing, just let's say the units. Let's say if there is a target is a Windows server. Okay, so the matrix would be the CPU capture, like CPU utilization. So that is a matrix to check the CPU. That is a matrix for that target, and there could be multiple, like number of requests, number of exceptions, HTTP requests, uh, like the amount of memory. So all these are the matrices. Okay. Now how this thing works. Okay. So first of all, I forgot to mention this is a pull-based tool. So it basically pulls the data from the targets. So there is no push in this. Okay. There is a push in one scenario, but I will explain that scenario. Normally, the monitoring tools which are available in the market, let's say we talk about the Amazon's monitoring tool. Okay. So that tools is a push based. So they basically, there is an agent which is deployed on the endpoints, and that agent is responsible to push the data to the monitoring server, and from there it will display with the any they do the formatting and then display on any GUI tool. But this is a pull based solution. It does not require any agent. It requires a certain exporters, but they only deploy an endpoint on the they only deploy endpoint on the servers or on the targets, and that endpoint is basically exported by the help of this retrieval worker. So I'm going to show you that as well. But let's first see what are these exporters. You can say these are jobs or exporters. Okay. So the role of these exporters are to get the data first of all. Okay. So there are three roles. The first role is to get the data. Second role is to make to format the data so that the Prometheus can understand. And the third thing is to get it available on a certain endpoint. Okay, let's just understand for this now. So there are three roles of this exporter. First role is to get the data. Second role is format the data so that Prometheus can understand. And the third thing is to get the data available so that this data retrieval service can retrieve from the endpoint. Okay, so this is the role of, so this is it works like on the pull basis. So retrieval is pull from the targets. So these are the targets you can see, like TNS, Q1, service discovery. Okay, now there is one more thing here is node. So what is this node? This is the node where Prometheus is deployed, and it stores all its data into that node. we can store this data on the remote server as well, or this is a local, or you can store in the remote server as well. Now, once we have the data, okay, so once we have the data, let's say we have data stored here. Now we have to utilize the data, correct? So now how we gonna see that data? So there is a specific, query language, this Prometheus query language, which this Prometheus server understands, and by the help of this query, we can fetch that data. Now, where to run the query? So there could be multiple ways to run that query. There is a specific, web UI for Prometheus. Then there is Grafana for that. Okay, or you can use any other API clients. So now, as I mentioned earlier, this PromQL is a HTTP server. Its responsibility is just to accept the HTTP request, or sorry, the PromQL queries coming from where? Coming from either Prometheus UI or from the Grafana UI. We can integrate Grafana with Prometheus. So they basically backend send the PromQL queries to the Prometheus server, and Prometheus server would, get the data from the storage, and it just creates a response and sends back to the wherever the query is coming from. Okay, now this push alerts and alert measure, I'm going to explain it in some time. And what is this push gateway now? Now, as I mentioned, like the Grafana, so I'm sorry about the push gateway. I mentioned about this is a pull-based tool. Okay, now the push gateways comes in the picture. Let's say we have a certain processes which are basically short time lived, or you can say the short lived jobs. Let's say there is a batch job which just runs for a few microseconds or a few seconds. So to capture that data, we cannot capture it on the pull job basis. So we need a solution so that whenever it comes, it just pushes the data to that metrics, to that endpoint, so that the data retrieval worker can get the data. So only for those scenarios we have a push gateway in Prometheus. So this push gateway helps to available the data at the endpoint, and the data retrieval worker can get that data. Okay, now I just want to go back, and I'm just gonna explain. Just a second. I think there is one more thing. Yes. So this data retrieval, as I mentioned, this data retrieval worker, the role of it's a pull mechanism, and on the target, which could be a Linux server or any pod or any Kubernetes component. This is a target, and there is an endpoint, the slash metrics. It could be metrics, it could be probe, or anything which we set up according to us. So there is a configuration. I'll go through that. So the responsibility of exporter is to available that data to this endpoint, and this endpoint, and this endpoint will the data from this endpoint will be retrieved by this data retrieval worker. And there is a specific time frame for that, like when it's going to retrieve. I'll show you that as well. Okay, so let me just yeah, so this is the architecture which we are discussing. This part is left, alert manager. I'm going to explain it. So now, first, what is like, as I mentioned, this what kind of language is this PromQL? PromQL. This is a Prometheus query language. Okay, so you can see this is this kind of query. Like we are querying from a tool, from a Grafana, or from the web UI of the Prometheus, that HTTP request total. So it's just going to give us a value, and or we can like query it like this, like HTTP request total for particular job. This job is set up on the Prometheus file, which I'm gonna talk about it just after this. Okay, so this is like a filter. Okay, this HTTP request total, inside that there is a API server job of API server name. Get that, and from that use this handler to get the data. So it will give us the data for this particular. Let's see. Like you can see this HTTP request total to select all the HTTP status code except the 4xx ones. So this is like, so there could be multiple, so let me just show you the file as well. Oh, why this is coming, just a second. Yes, yeah. And I think one thing which I forgot to mention about the type of metrics. So there are three type of metrics here. Okay, I talked about target, but I forgot to talk about matrices. Metrics, I talked like to get the CPU usage, to get the memory usage. These are the matrices. But now there are three kind of. First is the counter matrix. So this is a kind of a matrix which basically either increase, okay, or just reset. It's also mentioned here. It's either gonna increase or just reset. So now so yeah, so certain, like you can say the number of HTTP requests, okay, that cannot decrease, correct? That either be zero or like the increased. So number of requests, number of exceptions. So these kind of matrices lies under the counter. Then, or you can see it's a picture given by the Prometheus team. So you can see this is either increasing or it's the stable, increasing or the stable. So now if we talk about the other matrix is gauge. So it's GAU, the gauge. So this is a type of matrix which comes up and down. So for example, the number of pods, okay? The pods are coming up and going down, going up and going down. Or we can say the CPU utilization, or you can say the memory utilization. So this is kind of that. You can see the photograph. It's going up, going down, going up, going down, then coming down as well. Okay, then there is a histogram. So it just talks about a particular like time frame. Let's say if you want to monitor the utilization for a certain time frame, for how long it was low, for how long it was up. So that kind of matrices lies under the histograms. I believe there is a graph for the histogram as well. Yes, so it's a under the handler graph. You can say a particular time. So this is and then we have the Prometheus.yaml. So this is the most important thing. And then I want to talk about the exporters, which like how for installing exporters, we're going to discuss two exporters. One is the black box to monitor the endpoints, and the node exporter, where to like deploy it. Now, if you see this, so this is the basic and the default, the Prometheus.yaml. This is their official page on the GitHub. So first of all, this is the global configuration. Just wait for a minute. So this is the scrap config. This is the where we define our targets. Let's say if you want to monitor google.com, we will define it here, that to monitor the google.com. And this is the name of the job. You remember I showed you that if you want to under the HTTP, there is a name there which we want to check for the specific job. So this is the name of that job. Okay, here we define all the targets. Then there are the rule files. Just wait for that. Now this is the global configuration, which is applicable to all the jobs. But if we want a specific configuration scrape interval. This means scrape interval means after how much time the data will go to that endpoint, so that it can be retrieved by the retrieval worker. And the evaluation interval, this is for the rules. I'll explain it. Okay, this is just an alert monitor config. You can ignore it for now. So yes, so this is the global, and this configuration can be done per job level as well. So you can just copy this and get into the end of the job. So this can be done on the per job level as well. Now these, as I mentioned, there is in the there is an alert manager. So it comes into the picture here. Okay, so now, as I mentioned, like this Prometheus monitoring solution is there to give us alerts as well, because we won't want all the time when our database is down or anything bad happen, it just tell us that, because the monitoring solution is there to update us if there is bad is going about to happen. Okay, it's not happened already. We also want to alert us that this is going to be bad if we don't check it. So these rules are there to create the in the rules, so that let's say we have a very important application which we want, if there is a CPU of 50% is reached, we want an alert. So we have to define that alert in this part. So, and this is evaluation interval after every 15 seconds. By default it's 1 minute, but we can change it. So after every 15 seconds, according to this file, this rule files, we're going to check. It will check all the all the configuration, and if all the ports or all the targets, and if requires to be alert, it will gonna alert. And when they're gonna alert, this alert, according to the integrated software, could be a PagerDuty for ServiceNow, or it could be an email, or it could be any further monitoring tool, or any further maybe any ticketing tool. It want to raise the alert on that according to that. That's why it's here. So I think job. Now let's come to the exporters. That's the most important thing. So this is the configuration file. Now I'm gonna just show you. Yes. So so there are there are like multiple exporters. Okay. This is the Prometheus. In the Prometheus, you can go to the website and you can download. Now this is the Prometheus for Windows, Darwin, or Linux, or you can get the Export Alert Manager. So there could be like multiple exporters, but I'm going to discuss about like two exporters, the important ones, like black box and the node. So this black box exporter, if you just come here and see, so this exporter allows the black box probing for the endpoints over HTTP, HTTPS, DNS, TCP, ICMP, or there's all the protocols. And to configure this exporter, you see here, this is a scrap config and this is the job. Okay, we can configure this, the binary of this on maybe as a sidecar container, or on your Kubernetes. The practical would be on the next video, but you can also configure this on the server directly. You can this runs on a port 9115 and you can configure it. Okay, so here in this section, let's say this is our website. Okay, so and this we want to monitor. So this is running on the Prometheus server, and we are monitoring this website from the Prometheus itself. So that's what it is. Okay, so we are not doing anything on the target itself. We are just running this exporter on the Prometheus server, mentioning the URL or maybe IP address here, and we are just providing the target on this here, on this. This is a part of the configuration of Prometheus.yaml, and we have to restart the Prometheus services, and it's gonna give us all the monitoring and everything. Now for the node exporter, so if we see here, this node exporter will monitor the operating system matrices, the hardware matrices. Okay, I'm going to show you, and this by default runs on this port. Okay, so this obviously, if we want to export the OS matrices, this we need to it just runs as a process in the backend. It is not like any agent or something. We just need to deploy this process on the target server for the node, because that's only the possible way to export the matrices of the operating system. Okay, so but this is not an agent. Okay, as I mentioned, it's not a push base, it's just a pull base. So what this will do, it will just create it will just create an endpoint. It will, for as I mentioned, the three steps. First step would be to get the data. Second step, format the data so the Prometheus can understand, and the third step would be to just provide that all the formatted data to that endpoint, so that the retrieval worker can get the data and store into the Prometheus server, the storage. So all these matrices can be collected by, you can see here, all these units of the matrices. You can just check the GitHub of the Prometheus for that. I mean, this all is the theory, and which one thing I want to show. Yes, this endpoint, because this is a part of my next video. I'm just gonna show here that on the Prometheus UI, you can see this node exporter. So this is getting the metrics like this, or at the time of the configuration, this node exporter, we can configure it like this is my Jenkins configuration. This is Jenkins. So this is the IP of my Jenkins VM, which I want to configure, and this is the node exporter, and this is the Jenkins URL. So that's how we configure, and it is a part of the Prometheus. Yeah, it's part of Prometheus YAML. And on the UI of Prometheus, we can see this node exporter. It's up, and inside we can query using the PromQL. If you want to see the demo, how to install using Helm chart, or how we can configure this node exporters as the part of, or the Prometheus as a part of my sidecar containers, you can check my other video, and please do subscribe the the channel. Thank you so much.